Considering a 400 amp single-phase service with a rotary phase converter involves several factors. The cost of a 400 amp single-phase service with a rotary phase converter is likely to be significantly lower than bringing in three-phase power. A 400 amp single-phase service will experience less voltage drop than a three-phase service, which can be beneficial for the motor loads. Rotary phase converters typically have a low power factor, which can result in increased energy consumption and higher utility bills. Rotary phase converters are not as reliable as dedicated three-phase transformers. They can be susceptible to voltage fluctuations and power outages. To determine the cost-effectiveness of a 400 amp single-phase service with a rotary phase converter versus a dedicated three-phase transformer, you would need to consider the following factors. Firstly, the capital costs, including the cost of the 400 amp single-phase service, rotary phase converter, and 50 kV ampere transformer. Secondly, the operating costs, including the increased energy consumption and utility bills due to the lower power factor of the rotary phase converter. Thirdly, the maintenance costs, including the cost of maintaining and repairing the rotary phase converter. Based on these considerations, a 400 amp single-phase service with a rotary phase converter may be a more cost-effective solution if firstly, the cost of bringing in three-phase power is prohibitively high. Secondly, the voltage drop associated with a three-phase service is excessive. Thirdly, the power factor penalty associated with the rotary phase converter is minimal. And finally, the reliability concerns associated with rotary phase converters are acceptable. It is recommended to consult with a qualified electrical engineer to evaluate the specific needs and to determine the most cost-effective and reliable solution. The engineer can consider factors such as the size of the motor loads, the distance from the utility grid, and the availability of infrastructure to support a three-phase service. Considering voltage drop, it's crucial to calculate the expected voltage drop for both the single-phase and three-phase options under full load conditions. Use appropriate voltage drop calculators or formulas taking into account wire size, conductor material, distance, and load current. The National Electrical Code, or NEC, provides guidelines and tables for voltage drop calculations. For example, NEC Section 215.2 A on an informational note number 2 recommends a maximum voltage drop of 3% for feeders and 5% overall for feeders plus branch circuits. Exceeding these limits can lead to motor overheating, reduced motor starting torque, and inefficient operation. When evaluating power factor, understand that a low power factor increases the current drawn from the utility, leading to higher energy losses in the distribution system and potentially resulting in power factor penalties from the utility company. Rotary phase converters typically have a lagging power factor. Installing power factor correction capacitors can improve the overall power factor. The size of the capacitor bank needed depends on the kilovolt-ampere rating of the motor and the desired power factor correction. An electrical engineer can perform a power factor study to determine the optimal capacitor size. Consider the impact of harmonic distortion. Rotary phase converters can introduce harmonic distortion into the electrical system, which can negatively affect sensitive electronic equipment and increase losses in transformers and conductors. Harmonic filters may be necessary to mitigate these effects. The NEC Article 399 covers the requirements for power factor correction capacitors and harmonic filters. When it comes to reliability, rotary phase converters are electromechanical devices that require regular maintenance, including lubrication, belt adjustments, and contactor inspections. Regular maintenance can minimize downtime and extend the lifespan of the converter. A dedicated three-phase transformer is generally more reliable and requires less maintenance. Consider the motor starting requirements. The starting current of a motor can be several times its full load current, which can cause voltage dips and potentially trip circuit breakers. A rotary phase converter may not be able to handle the inrush current of a large motor, especially if it's undersized. Soft starters or variable frequency drives, or VFDs, can reduce the starting current and minimize voltage dips. When comparing costs, obtain detailed quotes for all equipment, including the 400 amp single-phase service, rotary phase converter, 50 kV ampere transformer, 3-phase transformer, switchgear, wiring, and installation labor. Factor in the cost of permits, inspections, and engineering fees. Estimate the annual energy consumption of the sewer pump and calculate the cost of electricity based on the utility's rate structure. Include any power factor penalties in the cost analysis. Also, estimate the annual maintenance costs for both the rotary phase converter and the 3-phase transformer. Consider the lifespan of the equipment and calculate the present value of all costs over the equipment's lifetime. Compare the present value of the single-phase with rotary phase converter option to the 3-phase option to determine the most cost-effective solution. Check with the local utility company regarding their requirements for 3-phase service extensions. Some utilities may require the customer to pay for the entire cost of the extension, while others may offer incentives or cost-sharing programs. Understand the utility's metering requirements for both single-phase and 3-phase services. Some utilities may charge a higher rate for 3-phase services, while others may offer time-of-use rates that can reduce energy costs. Also, consider the future expansion possibilities. If there is a possibility of adding more 3-phase loads in the future, it may be more cost-effective to install a 3-phase service initially. The NEC provides guidelines for sizing electrical services based on the connected load. For example, NEC Article 220 covers the requirements for calculating branch circuit, feeder, and service loads. Ensure that the electrical service is sized adequately to handle the existing and future loads. In addition to the NEC, local codes and regulations may also apply. Consult with the local building department and the utility company to ensure that the electrical installation complies with all applicable requirements. Before making a final decision, perform a thorough risk assessment. Identify the potential risks associated with each option, such as equipment failures, power outages, and safety hazards. Develop mitigation strategies to minimize these risks. Consider the impact of each option on the overall reliability and safety of the electrical system. Also consider the environmental impact. Rotary phase converters and transformers contain materials that can be harmful to the environment if not disposed of properly. Ensure that the equipment is disposed of in accordance with all applicable environmental regulations. When selecting a rotary phase converter, choose a reputable manufacturer and a model that is specifically designed for motor loads. Consider the converter's horsepower rating, voltage rating, and power factor correction capabilities. Ensure that the converter is properly sized for the motor load. When selecting a 3-phase transformer, choose a transformer that is specifically designed for the application. Consider the transformer's kilovolt ampere rating, voltage rating, and impedance. Ensure that the transformer is properly sized for the load. When installing the electrical service, follow all applicable safety procedures. Use qualified electricians and ensure that all work is performed in accordance with the NEC and local codes. Inspect the installation thoroughly before energizing the equipment. After the installation is complete, perform regular inspections and maintenance to ensure that the equipment is operating properly. Keep accurate records of all inspections and maintenance activities. In addition to the technical considerations, also consider the aesthetic impact. Electrical equipment can be unsightly, so it's important to choose equipment that is aesthetically pleasing and that blends in with the surroundings. Work with an architect or landscape designer to minimize the visual impact of the electrical equipment. Finally, communicate with all stakeholders, including the property owner, the utility company, and the local building department. Keep them informed of your plans and address any concerns that they may have. Collaboration and communication are essential for a successful project. To elaborate on the selection of a rotary phase converter, it is important to understand the different types of rotary phase converters available. There are idler-type rotary phase converters and solid-state rotary phase converters. Idler-type rotary phase converters use an induction motor as an idler to generate the third phase. Solid-state rotary phase converters use electronic components to generate the third phase. Idler-type rotary phase converters are generally more reliable and can handle larger motor loads than solid-state rotary phase converters. However, they are also more expensive and require more maintenance. Solid-state rotary phase converters are less expensive and require less maintenance, but they are not as reliable and cannot handle as large motor loads. When selecting a rotary phase converter, consider the following factors. Firstly, the horsepower rating. The horsepower rating of the rotary phase converter should be equal to or greater than the horsepower rating of the largest motor that will be connected to it. Secondly, the voltage rating. The voltage rating of the rotary phase converter should match the voltage rating of the electrical service. Thirdly, the power factor correction capabilities. Choose a rotary phase converter that has power factor correction capabilities to improve the overall power factor of the electrical system. Fourthly, the starting current capabilities. Ensure that the rotary phase converter can handle the starting current of the largest motor that will be connected to it. Fifthly, the manufacturer's reputation. Choose a rotary phase converter from a reputable manufacturer that offers a good warranty. To further discuss transformer selection, understanding transformer impedance is crucial. Transformer impedance is the opposition to the flow of alternating current and is expressed as a percentage. Transformer impedance affects the voltage regulation and short-circuit current of the electrical system. A lower impedance transformer will have better voltage regulation but will also have a higher short-circuit current. A higher impedance transformer will have poorer voltage regulation but will have a lower short-circuit current. When selecting a transformer, consider the following factors. Firstly, the kilovolt-ampere rating. The kilovolt-ampere rating of the transformer should be equal to or greater than the total load that will be connected to it. Secondly, the voltage rating. The voltage rating of the transformer should match the voltage rating of the electrical service. Thirdly, the impedance. Choose a transformer with an impedance that is appropriate for the application. Fourthly, the efficiency. Choose a transformer with a high efficiency to minimize energy losses. Fifthly, the manufacturer's reputation. Choose a transformer from a reputable manufacturer that offers a good warranty. The location in Indianapolis might have specific code requirements or utility regulations that need to be considered. These might involve local amendments to the NEC or specific requirements for connecting to the utility grid. Checking with the local authorities is essential to ensure compliance. When evaluating the cost of bringing in three-phase power, it's important to get a detailed breakdown of the costs from the utility company. This should include the cost of extending the three-phase lines, upgrading the substation, and any other associated costs. Compare this cost to the total cost of the single-phase with rotary phase converter option, including the cost of the equipment, installation, and ongoing maintenance. Remember to factor in the long-term costs and benefits of each option when making your decision. Finally, document all of your findings and recommendations in a written report. This report should include a detailed analysis of the costs, benefits, and risks of each option. It should also include a recommendation for the most cost-effective and reliable solution. Share this report with all stakeholders and use it as a basis for making a final decision. The NEC has specific articles relating to the installation and wiring of transformers, including but not limited to Article 450. This article provides guidance on the location, ventilation, and protection of transformers. Following these guidelines is crucial for ensuring the safe and reliable operation of the electrical system. When installing a rotary phase converter, be sure to follow the manufacturer's instructions carefully. Improper installation can damage the equipment and create a safety hazard. Use qualified electricians to perform the installation and ensure that all work is performed in accordance with the NEC and local codes. Grounding is a critical aspect of electrical safety. Ensure that the electrical system is properly grounded in accordance with the NEC Article 250. This will help to protect against electrical shock and equipment damage. Use appropriate grounding electrodes and bonding conductors to create a low-impedance ground path. Surge protection is another important consideration, especially in areas that are prone to lightning strikes or power surges. Install surge protective devices, or SPDs, at the service entrance and at sensitive electronic equipment to protect against voltage transients. The NEC Article 280 provides guidance on the selection and installation of surge protective devices. In addition to the technical considerations, also consider the operational aspects of the electrical system. Ensure that the electrical system is easy to operate and maintain. Provide adequate lighting and ventilation in electrical rooms. Label all equipment clearly and provide training to personnel who will be operating and maintaining the electrical system. A well-designed and maintained electrical system will provide years of reliable service.